الله سبحانه وتعالى زين البحر كله، لأنه سبحان الله ينمو بقدرة الله سبحانه وتعالى يطلع. فهذا البحر أرزاق، لكنه أرزاق. أحسن مهمة للسمك هي المساكن. المرجان ذا فيه يبيض فيه سبحان الله. بعدين عندما يريد الله سبحانه وتعالى كأنه يفقش، يأثر يا ابوي. لو انفقد المرجان يأثر، لأنه دحين نشوف دحين الإنسان لما يكون ما عنده بيت، الله ما يخلق شيء عدل، كل شيء يخلق فيه فايدة.
We get these big picture expedition questions in different areas that we go, and our responsibility is one, like how do we translate those objectives? And then how do we bring people together who have complementary objectives, and how do we get them the tools that they need to get the work that they need to get done? They could have a very hyper-specific expertise in a variety of things. For example, we have some coral reef specialists on board that are just exceptionally talented at what they do.
The expedition overall has been running for 4 months, sampling stuff across the whole Red Sea.
Everything starts with a map. So Kate and the survey technician on board work is instrumental for us to begin ops and to know where we're going and how to plan dives and how to look for the things that we're interested in.
Having a vessel like this and a place in the Red Sea where you can pull a huge ship up right next to the reef, we have the ability to profile the water column all the way down to the bottom, collect data in real time, and exactly the sort of stuff I'm interested in trying to use to get a better sense of what is going on just beyond the reef.
We are on the south side of Al-Waj Canyon area. Throughout the entire Red Sea missions, we've actually done a lot of dives in this area. And yeah, that's what we get to do today.
This Red Sea mission from Innaport. So we've been all the way south to Parasan Island, to the Gulf of Aqaba, all the way up to the Jordan border.
The Red Sea is an amazing place. I mean, I haven't been working here all that long, but it's remarkable. The reefs are spectacular. Just piles and piles of corals of different shapes and colors and sizes. Truly magnificent. They've probably been spared more so than reefs in other parts of the world over the last several decades. It's kind of closed off from the rest of the ocean. There's a small strait in the south, and that's basically the only thing that connects the Red Sea to the rest of the world's oceans, which has created a really high level of endemism, and that's a term for organisms that aren't found anywhere else in the world. They came in through that strait at some point over a long time, and their populations never left, and so they've evolved to be unique organisms that are found only in the Red Sea. So you jump in the water here, and I've worked on reefs all around the world, and you can see things that you recognize, but when you look closely, many of them are subtly different. The dives are really fun. It's an exciting place to get to learn new species, see new things. It's an amazing place to do science.
And this is going to be the dive site. It's going to be a wall. The top area is about 2 meters or so. and it drops down to about 15 or 20, and then it kind of stands off around about that area. And we are going to stay at about 10 meters. So we have the ROV doing the really deep stuff, and the subs doing the intermediate stuff, and then we're doing everything from like 30 meters to the surface.
The term symbiosis is in reference to organisms or animals in the ocean that are dissimilar, that live in close physical association. Coral reefs have symbionts. The macroalgae is using that coral structure as protection, as shelter, and then that photosynthetic algae is bringing in nutrients and food. The easiest way to visualize a coral reef like an underwater city, and I currently, when I'm not on the ship, live in New York City, and I always think, wow, it's so loud and so diverse, and there's so many different people doing so many different things, all contributing to what makes that city thrive and what makes it special and what sort of supports the city's economy and the relationships people have within it. So when I think of coral reefs, I think of all these different species that make up that underwater ecosystem all working together. And the more biodiverse a reef is, the healthier it is, and also the louder it is. The reef is actually quite loud.
Some of the most important biodiversity in the world is housed in coral reef systems themselves. It's a little awkward coming in this way, so. This is the wet lab, by far the busiest place on the ship.
I need sample 2, 3, and 4.
All the samples from the subs, from the ROVs, from the CTD, and from SCUBA all converge, and the scientists basically split up into teams, and then we all process samples.
This pink stuff that looks like a rock is actually an algae. We call it crustose coralline algae, or CCA for short. You can think of it as like the cement that holds the coral reef together. So corals build the skeletons, which creates the framework and the structure, but this algae is what keeps everything together. When pieces break off, this can glue it back down. Over time, this will cement loose pieces together and help build the mass of a reef. So without this, reefs don't work the way they're supposed to. The reason it's pink is part of the pigments that allow it to catch the little bit of light that goes all the way down to the depths. So here in the Red Sea, people know very little about CCA. This algae creates a safe space for juvenile corals to land. An abundance of this stuff also helps baby corals recruit and reestablish reefs. Corals are related to jellyfish, and they have a symbiotic relationship with the microscopic algae. So those are tiny plant cells, basically, that live inside the coral animal and allow it to harness energy from the sun. And that relationship is very sensitive to temperature. So a degree or two of temperature change can cause that relationship to break down. And in response, sort of like we get fever if we're sick, when the corals start getting stressed by temperature, they actually expel those algae from their cells. So the term bleaching comes from the fact that once the corals have kicked out their algal partners, the jellyfish tissue of the coral is translucent, so you're looking through the animal at the white limestone skeleton beneath it. If it stays bleached for too long, corals ultimately sort of starve to death. But if the temperatures cool off, corals are capable of regaining their algal symbionts, regaining their color, and continuing to grow. I started diving in 2004. Spent a lot of time in the tropics. 2015 was the largest coral bleaching event globally that devastated a lot of reefs around the world. I was in the Maldives in like mid-2015. Saw some of the most beautiful reefs I've ever seen. Was just there 2 months ago, 30 miles away from where we were before, and it was completely devastated.
The more CO2 we release, the warmer the atmosphere is going to get, and as more CO2 goes into the ocean, the more acidic the ocean becomes. Corals are made of calcium carbonate that is basically crumbling away in the acidity of the ocean.
starting in 1998, things have been pretty extreme for reefs. That was the first big global bleaching event that everyone sort of started paying attention to. We had a couple more in the early 2000s, and then 2015 was truly unprecedented. The water around coral reefs across most of the tropics was warmer than we've ever seen. So it's a wake-up call.
If we continue acting like we do, a lot of the biodiversity is probably going to vanish. A lot of scientists speak of the time now as one of the new big mass extinctions.
The metal shark is a tender on the RV Ocean Explorer, and in 2021 we outfitted it with a multi-beam sonar. When I went to graduate school, you have to do your essay and everything to go get in. And I remember writing about what I wanted to do in my future, and it was very focused on the unknown in the ocean and wanting to close that gap, being able to contribute to this very large field that has a lot unknown. And what I'm doing is such a small percentage, but it feels great to be a part of that percentage.
So we launched the small boat from the big boat and sent it out to do a mapping mission.
It's a smaller system and it's higher frequency, and we use the system to augment our mapping with the ship. And this allows us to get higher resolution, high definition data in these really shallow water areas.
What I'm going to do first is bring in some of that data we just collected, because when we're mapping with metal shark, we match up with the data that we got with the ship. So now we're getting that entire seafloor elevation change from 2,000 meters, 1,000 meters, going up 200 meters, and then up to the 10-meter contour. We get that shallowest depth with metal shark.
I can show you which part we did. This was the mapping area that we got with the metal shark, and it kind of comes right up to a shallow reef area. We do several parallel transects, and so each color here represents a different line. So you can see here there's like quite good overlap between the different colors, which means, you know, we basically got the same feature twice, which we can pretty confidently say that that is probably accurate.
I knew from being like a little kid, I didn't know it was exactly this that I would be doing, but I knew it was something that would take up a very big portion of my life. And this is it. I love being up here at night. We are currently 12 miles off the coast of Saudi Arabia, heading southeast towards the land, doing some mapping. We ops in the daytime, generally, so sub, ROV, scuba, and heli in the daytime. Once we finish those ops, we're immediately in the mapping most days, all through the night until we arrive on station in the morning and then start the operations again. 24/7 contributing to science. One of the most rewarding things I've had from mapping is when you're doing it, you don't realize how much that you're doing until one of the mappers at the end of the mission actually prints off one of the charts and you see the sheer area that you've done, and this is like an entire sea that we've mapped in one mission. This is us right in the middle here, and coastline over here, the distance here. So we've got the echoes all along the side. That's from the radar showing us that coast. Turn them off. So that's the chart there showing that the coast is around this area, and then we turn our radar up, and then we can actually see confirm, yes, that is land there. around this area. All of these ships are using the same chart survey, and yeah, some of them is literally from like the 1800s. Lead line survey, just some guy in a boat dropping a lead line, kind of guessing where it is. It's definitely a moment of maximum interest when the charts, the official charts, are saying that you would ground the ship, or that it's like a rock here or 5 meters depth, and over time it's now changed into 500 meters or more. It's crazy to see the difference between the charts and our real information that we've got in front of us right now. What we're doing right now will be used for probably more than 100 years, and by everybody, and that's pretty cool. This is us right now. Here's the lines coming down here. You can see pretty close to the reefs. Map those areas and the dive spots in the morning, probably around there. 65 people just asleep at night in their bunks, and we're mapping so close to the reefs and fully switched on, navigating, and yeah, everybody's just asleep dreaming away.
Morning guys, how are you all doing? Today's dive is going to be Site 3, south of Duva. Planner is 8:30 in the water, 4:30 back on deck. It's going to be a standard dynamic launch and recovery. The weather is feeling good, according to the forecast, maximum gust of 18 knots. It's going to be approximately 430 metres, and then carry on with the science from there. You guys can get your samples. Okay, I'm going to hand over to science first. What would you like to achieve today?
We definitely need some roasted torcas, some sponges, some whipped corals are requested from Mike, and then pancakes, and then hopefully, if the current allows it, focus the sampling of it on the mesopotic.
Okay, everybody happy? Pack lunches will be provided, and they're sitting on top of the sub as we speak. Fantastic.
Descending, over.
Food's coming your way.
Control, this is Neptune, over. Control, this is Neptune, over. Control, we have lost all power. Slight smell of burning. We are X-ray, over. Not part of the Control, this is Neptune off bottom, ascending, over. Down, mate.
We're flying.
Yeah, we're going up real fast.
Okay, everybody okay? Yeah. Control, this is Neptune. Throttle breakers off, tanks are blowing.
The sub-pilot team on Ocean X are literally the best in the world.
We lost all power on emergency power, over. Deadbolt.
It's pretty awesome to watch Alan snap into action and lock it down.
Affirmative, all well.
It was tough to just disentangle reality from fiction in a sense. It reminds you that while it might feel comfortable and sort of normal to be down deep in these subs because they are such capable vehicles, there is an inherent danger in operating at depth. So this was a good reminder that you are out of the element of humans, and you need to take these expeditions and these opportunities very seriously.
The yellow is actually our main ballast tank, which is our air ballast. We've got a few other methods to maintain buoyancy underwater, but that's the main one we use at the surface. And then a variable ballast underwater, so it's different systems for different applications. And the big thing for us is redundancy, so we've always got a system to back up a system. If you happen to lose something at 1,000 meters, you just want something to step into the role that'll... Main thing is making sure everyone can come back up to the surface. This is the submersible hangar on Ocean Explorer. As you can see, we've got two submarines just behind us here. They're both the same model, Triton 3300-3. They take 3 people all the way to 1,000 meters. The pilot sits in the middle at the back, and the 2 passengers on either side. It's a pretty typical setup. These are just big collection boxes, so we can hydraulically open and shut these under the water. So corals, rocks. This trip we've been focusing on deeper corals and CCAs, so a good collection for them. We have our suction sampler, which is essentially an underwater vacuum. So we can grab that with a manipulator, turn on the suction through a water pump up there, and essentially just get over to the nice smaller organisms like sponges and stuff, and just suck them straight up in. You can see the lights, which allow us to see underwater, because at 1,000 meters there's not much light. The Red Sea, you can actually navigate quite well down to about 300 or 400 meters. You can't see detail, but you can definitely see the bottom and avoid obstacles. But the deeper you go, and in other parts of the world, it's pitch black, so that's obviously a must-have. Up the top there, we've got a forward-facing sonar, so we can see up to 100 or 300 metres ahead, and then obviously scale that back if we need to, allows us to see what's coming, avoid obstacles, and also to find things underwater. If we're looking for certain rock features or maybe a camera we've laid down the day before and we're trying to come back to it, it's really, really handy. Science camera, so it's HD with scaling lasers. We've got 6 thrusters, so very controlled, very stable underwater, so we can get really nice and close to the walls of the samples. And the workhorse is this, which is the Schilling T4 manipulator, which is an amazing piece of kit. We all love to use it because it's incredibly dexterous, incredibly strong, and it's just a lot of fun to use. Yeah, it's an amazing technology. And as you can see, visibility is phenomenal inside. It's actually made in 2 hemispheres bonded together. It's 7 inches thick. We do get to work with great scientists from around the world, so that's the best bit of both worlds, because I have a science background, I have a great appreciation and love for it, but I also prefer personally the hands-on type work, so being able to work with a scientist and then also just give them the data and move on to the next project and then find out 6 months later all the cool stuff we actually found is perfect for me.
We collected samples for everyone in my lab. We are interested in water samples, corals, sponges for my own lab, but also we have Susie's lab and Mike's lab, which are also collecting different types of biosamples.
The reefs of the Red Sea are naturally adapted to higher temperature water, saltier water, sort of the climatic extremes of life in the Middle East. You know, there's a lot of work being done now to sort of understand what the upper limit of some of the world's most heat-tolerant coral communities are, so we have a better sense of how far they can be pushed in the context of climate change.
The Red Sea is often called a living laboratory. We have very hot summers, we have colder winters, so the corals are experiencing much bigger differences in temperature over the years, so we can actually go out in different parts of the Red Sea even and start comparing environmental conditions, how corals respond.
We have some mesophotic corals. We informally call them pancakes because they look like nice pancakes underwater. They live in the mesophotic area where there is still a bit of light coming through. They have the symbiotic algae living within their tissue, and they can harvest energy from sunlight. Pancakes and all the mesophotic corals is still a field that is at its infancy. Lately, with all the new devices like SAPS and ROV, and also with new scuba equipment, we have started to study them. They must be very important. They cover only 0.1 of the ocean surface, but on the other hand, they host a very high biodiversity. We don't know if they might be refuge for corals in the future, so it's very important to expand our knowledge on this species.
In summer, it gets up to 32 degrees, and the corals are still managing quite well. The idea is to find out what are the mechanisms that make these corals more resilient to temperature, and how can we maybe take them and apply them at another place to help corals be more resilient in different temperature regimes.
So this is a multispectral sensor. The difference is, like you and I, we see in red, green, and blue. Then you have shortwave and long-wave infrared, which gives us data that we're not visibly able to see. That picks up a broader spectrum of different light spectrums. Green breaks down the green to a few, breaks down the red to a few, breaks down the blue to a few, breaks down the infrared to a few, and the ultraviolet. Everything has a different reflection. So basically, the multispectral sensors will give us some indication about the reflective light that we can't see with our visible eyes, and that reflective light can give us different indices about plants, or in our case, coral and stuff like that. So we're comparing the lower price, easier to manage, multispectral with higher end, more resolution, hyperspectrums, doing some autonomous drone flights over shallow water, nothing deeper than 15 meters, and then compare the data that the divers have collected during their transects of the coral reefs. So drones will cover a greater area at the same period of time, but we need to have that data from the divers to do the ground truthing when we're developing the AI to process this data. If we can have units of these scattered around the coastline with conservation teams, we can have more rapid coral assessment done when there's events of bleaching or something going on. It will just help us gather enough data to make the right decision at that time.
So Alex, in this direction we have north. We have a big shipwreck over there in this, not far away from us actually. It was grounding in 1969, I think it was. Utrolig reise fra starta på verkstedet i dammen, og vi kan se nå hvordan båten ser ut. Det startet med renderings, og nå ser båten akkurat sånn som så ut på de tegningene. Sånn, hvor en utrolig reise. The amazing thing is the propulsion system from Rolls-Royce, you know. We have azimuth thrusters that we can turn 360 degrees. And we have two bow thrusters. And we also have one extra bow thruster that's retractable. And that's good to have, and it's, let's say, over 45 knots wind. I've been at sea since I was 16 years old, you know, starting on the fishing vessels in Norway. Where I come from, you know, then it's very close to the Barents Sea and the North Sea and the Mediterranean and crossing the North Atlantic many times and the Red Sea, yes, so, and Caribbean, many places. So growing up with the sea, you know. We have been here 4 months, you know, so we have covered many square meters with mapping and also with other science work. So we have mapped the area, so next time we come back now, it's safe for us. We will be heading to the northwest, and we will try to slowly move ahead and have both of the subs. When subs are below surface, we will move to starboard and be ready for the ROV. We will always have the subs on the starboard side.
The ROV is a remotely operated vehicle, so we have a lot of cameras on it, and then the two arms is replacing a diver as such. This ROV can go to 6,000 meters. It's like I think covers 96% of the ocean, so it's a deep.
It's discovering what hasn't been discovered. It's trying to help these guys advance science and learn more. Yeah. In my industry, it doesn't get any better than this.
For this dive, we're going to be collecting some corals, hopefully crustaceans, CCA, which they look kind of like pink rock. Pink potatoes is what we call them. We need to collect 3 sponges below 300 meters, like yesterday, and then the Rhizotrochus below 150 meters, and as much time as possible in the Mesophotic. About 450 meters. There's some sea urchins and some sea urchin roads.
Total right now, 27. We're going to get probably another 2 or 3.
We also are interested in the plastic litters to see how humans impact the environment. Actually, today we saw the zip tie, we saw a plastic bottle. One sample of sediment, and we could see that it had a lot of degraded plastic. We do see a lot of plastic litter, even really, really deep. We saw small particles of plastic, but we also saw like chip bags and also plastic bottles, and I was not expecting that. I would expect more the small particles, but yeah.
I never thought I would get to go on a ship. I never thought I would get to go on a submersible or seeing that spaceship room here. And not so many people get to experience what's under the surface, and I just always loved it. You never know what you find.
Trip of a lifetime. I just got out of a helicopter. We went down in subs the other day. We just had an incredible dive with the ROV on a beautiful Mesophotic reef. These are parts of the ocean that most people never get to see.
very strange. This species lives down there in that deep, 1,737 meters. For me, I didn't work in that depth because I work in only 1 and 2 meters. There is many researchers who work there. For me, it's the first. This is the first species I found there. The mollusk, I didn't expect to see this species down there. It's a chance to join Oceanix to work in here. You know, so I have a many facility to work as submarine and ROV. Good for me.
This is sediment that we collected, and they are going to do environmental DNA analysis afterwards. Basically, environmental DNA is all the DNA that animals shed in the environment. So, like, for example, through skin shedding or through feces and whatever. It just stays for a while in the sediment. We hope to look at different genomes of different species and also to trace back what species were present in the Red Sea back in time.
I was always told that marine biologist wasn't a real job growing up. You know, only a few people get to be on Shark Week or the Discovery Channel. And I've done some pretty cool stuff in my career, but this is the closest I feel to being on the Discovery Channel. But this is the real thing.
We found a large ray 1 mile to your north. And there's also a whale shark with a baby whale.
Well, we got a whale shark and a baby whale shark.
You still have a good 150 meters.
Okay, copy that. 150 meters, guys. I mean, thank God for the helicopter. There it is, I see it. Okay, guys, I've got eyes on it. Probably 50 odd meters. I see it. Just wait, get your camera, Go, turning. Sam was right in front of it. A few meters in front, it just turned sideways, went down, right over the top of the reef and then away. It was absolutely fantastic.
All these resources, like finding the animal, getting to the animal, and tracking it. And yeah, towards the end, I was like right on top of it. The tail was just kind of like right in the camera. I thought it might hit me, you know.
Got the surface support guys, Zodiac captain, jumped in the tender, and then we were in there in like 20 minutes. And then the helicopter was above us, and he was actually letting us know, like, okay, whale shark to your port side, 20 meters on your bow. It was just like incredible. And Sam got some really good footage. So, yeah.
I was working on helicopters in Alaska where we're trying to find gold or trying to find oil, and those projects are kind of assisting in ravaging the planet a little bit through human resources. A guy that used to be flying on this boat called me up and he said, hey, there's a mechanic opening for this boat. Would you be interested? And he sent me all the links to the boat, and I was like, wow, this is like right up my alley. Like, I love being on the water. I get to support science, and see places, most people don't get to see. Environment like this, the most important thing is keeping the salt off of it. Since this helicopter is mounted on the bow, it's subject to a lot of wind, a lot of salt spray. So it getting an external wash and an internal engine rinse every day is the most important thing you can do on a boat for a helicopter. I know ASTARS pretty well. I've been working on these for 9 years. These aircraft are produced in France, and the engine's also produced in France. It's a gas turbine. It produces about 1,000 shaft horsepower.
The engine's rotating at like 50,000 RPM, incredibly fast. And it gets reduced in this reduction gearbox from 50,000 RPM to 6,000 RPM to about 395 RPM. That's what the main rotor's spinning at. Key component, the pilot. Gotta have one. Sometimes.
Most likely to break.
I've done some work off of a boat and then also some work off of oil platforms. So you get kind of used to landing on just elevated platforms in the middle of the water with those things. The difference with the boat versus a platform, the platforms are totally stable, or just about totally stable, and the boat can be pitching around a little bit. From above, when the sea state's pretty calm, or especially if the water's shallow, you can see animals. You see a lot of rays. They really stand out against the bottom. And the reefs are wild. So much of the work that we've done over the years don't necessarily feel so great about it at the end of the day. And helicopters are just such an amazing tool. It's nice to, like, you know, use our power for good. I think everyone's excited about what we're doing as a boat and then what our parts are.
I always found symbiosis super interesting, two organisms living very close together. Isn't it super fascinating that two organisms that are not necessarily the same taxa, so the same group, come and live together and benefit from each other? That connection between two unrelated organisms is so interesting from an evolutionary perspective.
Symbiosis, you can think of it as a mutually beneficial relationship between two organisms or people. Both partners live in close association and both get a benefit from that relationship.
Why there are two samples there? Is there anything lunch in these debris?
You could safely say that there is some sort of symbiosis in science. Oftentimes, people with different perspectives and expertise, when they work with or communicate with scientists from other disciplines, collectively those ideas feed off each other.
Come up a little bit.
We have ideas as scientists all the time, but 90% of the time it's like, well, I have no idea how to do that. And that's largely because we don't have a technology that someone in a different field might use all the time.
We haven't been around here, we were up in here, so this should be matching up.
Thanks, Kate.
You're welcome.
Technology is changing so rapidly, and it's allowing us to do things at such different temporal scale, from mapping the whole Red Sea to observing things on a cellular level, that individual scientists can't even necessarily keep up with a lot of these changes. The solutions are incredible. It will, for sure, change the way that we do science.
طازة هذا طازة هذا سمك طازة اسمه سيجان شبيحي هذا سيجان باحة هذا شبيحي هذا تلماني تموره ممكن تموره ما في يشتري ممكن خلاص برا.
A lot of the work that KAUST colleagues are working on right now are trying to find defined scale gradients across the Red Sea landscape to determine where those pockets of heat-tolerant corals are, which regions are more or less susceptible to rising ocean temperatures.
We were able to cover a huge area of the Red Sea, which allows us a more in-depth assessment of the biodiversity. So we covered everything from shallow to deep with the samples we took. And having such an extensive data set allows more robust analysis and, in the end, outcomes and answers that we find.
We have multiple tanks in here in which we have corals from the Red Sea, 2 species that we're currently working with, and we basically can control the conditions in every room and in every tank. We have Galaxia, which is a really, really nice species. You can see their green fluorescence and the tentacles. They're always nice to look at because their polyps are out. You can actually see the tentacles. We need this kind of research to try to understand coral reef degradation. The high temperatures lead to a breakdown. So one of the things that we're looking at is, can we improve the resilience of corals by specifically selecting the parents? So look for parents that are already more resilient and try to just increase their proliferation rates by specifically crossing them with many, many other colonies. If you're a species that releases the gametes into the water, then you have to make sure that all do it at the same time. And this is done by synchronizing the colonies using the moon light, specifically the full moon. And we can control it here. If you look at the lights, you see that they're blue LEDs. And at night, during the full moon, we only have the blue LEDs on. So these lights do not only provide light during day, they also mimic the natural moon cycle at night. So we need to find a way where we can increase the traits that we want while still retaining a natural population that has a high genetic diversity. Maybe they're more resilient to temperature, but they've also been selected to be successful at this specific location with all its environmental parameters. The idea would be to try to inject these genetic traits into the local population by crossing it with many, many local corals, so that you retain all the adaptations that you need for the corals to be successful where you want to do the restoration, and just inject this additional trait of increased temperature resilience into the population.
I can show you here. So we have this very shallow water tank where we have these small recruits that we can grow out. Here you can see that the skeleton, the white side, this tissue is actually overgrown onto the tile. And this is what we try to foster over time. So the tile actually submerges within the colony. After hammering the nail into the substrate, we have this screw system where we can screw them on. So they have a small RFID microchip. So if this dies, I can unscrew it, I can bring it back to the boat. I can then see, okay, is there a certain genotype that doesn't perform in a certain area? And how can we learn from this to become better at restoring reefs? With this restoration approach, can we actually enhance the number of individuals that have heat resilience, and you really go into a planning stage where you want to create a landscape underwater with a biological and ecological context. And we can really become underwater gardeners. This is kind of like a bio-vault. Imagine there is a bleaching event. Here we can then reduce the water temperature and keep this as a resource, as a stock, to then be propagated and to boost the local populations again. We don't lose all the diversity of a certain region. And we can do 500 square meters in one day with a dive team of 6 people. I eventually want to be able to go to a healthy-looking coral reef and show it to my children, or even my grandchildren, that can be enjoyed by future generations to come.
حياتي هو البحر. أحب البحر. أحبه من الله كذا.
The ocean ecosystems have been around for a very long time. And they have gone through multiple mass extinction events. As things change, so will the ocean. Life is pretty good at adapting. We could see a huge loss of biodiversity, but the oceans are not going to turn into dead zones overnight. Right now, we're seeing very rapid change. One of the outstanding questions is, what's the rate of evolution matched with the rate of environmental change? How does that change the scenario relative to mass extinction events we've seen in the past? But I think humans, we have a particular set of needs, and as I think we're seeing more and more regularly on the news, it's becoming more difficult for us to inhabit places that we've inhabited in the past and to extract resources that we've relied on for hundreds of years. So it's going to be much harder for us to continue living the lives we're accustomed to.
ترى في من الناس سكرية بس يناظر البحر. من اللي ما يحب البحر؟